Find the volume of the solid formed by revolving the region bounded by the curves y equals x squared and y equals x cubed around the x-axis. Leave your answer in terms of pi. Let's get a visual. All right, let's get a visual. Y equals x squared is going to look like u. Perfect. Y equals x to the third is going to look like u. So we have this tiny, 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 tiny little sliver right here. A tiny little sliver right there. And what we're doing is we're rotating it around the x-axis. And by rotating it around the x-axis, we don't get what we normally think we get. We don't get a solid like we did in the last couple sections. We kind of get this cup, this actual empty looking like a wine glass type thing is what we end up with. So we're not going to use the regular disk method that we're used to. We're going to use the washers method. Now this is called washers, just like the tool where you have the hole in between. That's kind of what we're dealing with here. We are dealing with a shape that, is like a cup. It is solid, but the inside is hollow. So this is the washers method. The washers method is found by doing pi times the integral from a to b, and we'll figure out what a to b is in a minute. We're going to take your original equation, so labeling you f of x, right? Or whatever one is f of x. One of them is going to be f of x, one of them is going to be g of x. So let me not label things yet. Okay, we're going to take one equation, f of x, we're going to square it, and then we're going to subtract g of x, which is going to square that too, and then dx. So this is different from the disks method around a different axis because we're taking into account that hollowness right there. Okay, now according to the picture that I drew out, my top equation appears to be x to the third, and my bottom equation appears to be, or do I have it backwards? No, my top equation is actually x squared. So that's my top equation is going to be x squared. So you are going to be f of x, and you are going to be g of x. Now, does it matter? No, because what I get is like the same exact answer, but negative, and I'll just make sure it's positive because I'm not stupid. I need my limits of integration, though. And my limits of integration are going to be found by me taking these two equations and setting them equal to each other. So x cubed equals x squared. Subtract x squared from both sides. Factor out an x squared, giving you x minus 1. And you get 0 and you get 1. Those are my limits. So the equation that I set up for this problem is going to be pi times, or the integral from 0 to 1 of x. So I'm doing x squared minus x cubed squared dx. That's going to equal pi times the integral from 0 to 1 of x to the fourth minus x to the sixth dx. Now let's integrate that. Okay, 1/5 x to the fifth minus 1/7 x to the seventh, limits at 0 and 1. No big deal. Let's plug in 1. Pi times 1/5 times 1 to the fifth, easy peasy, minus 1/7 times 1 to the seventh, easy peasy, minus, let's use common sense, if I were to plug in 0, I'd get 0 minus 0, which is 0 times pi minus 0, so you get that. Pi is still living on the outside. 1/5 times 1 to the fifth is 1/5 times 1, which is 1/5. Minus 1/7 times 1 to the seventh is 1/7 times 1, which is 1/7. Did you catch all that? Now we have 1/5 minus 1/7, so let's multiply the top and the bottom by 7 and 5 respectively. 7/5, 35ths minus 5/35ths is going to be 2/35ths. And 2/35ths times pi is 2 pi over 35. Dog.